In our previous courses, we discussed traditional programming and machine learning models. We saw that in the traditional programming model, data and rules were input and evaluated with conditional statements in a sequential manner, and then the answers were output. In our Python's foundation flow, we will concentrate on the traditional model to introduce all the general programming concepts that we'll need when we start implementing our own machine learning models, since all of the general constructs we cover will still apply. Now, all programming languages include the ability to implement conditional statements, and the way they do this is by evaluating statements using comparators. In Python, the comparators we used are defined here. Each of these operations is pretty intuitive, and we'll show their use in some examples later. One important note of caution, though, is with the equal comparator function. Please note that checking if a variable is equal to another is done using the double equal operator. One of the most common programming errors is for a programmer to mistakenly use a single equal operator in a conditional statement, which simply makes an assignment and does not implement a comparison operation. This is easy to do if you're not careful and will not usually throw an error when the code is executing, so it can introduce some nasty bugs that are hard to track down, especially if you have a lengthy and complex piece of code. We are also able to condense our code a bit by using compound comparators as shown here. The three basic functions include AND, OR, and NOT. Each of these operators implement a Boolean logical function. The AND operator requires all input conditions to be true in order for the output to be true. The OR operator requires at least one, but not all, of the input conditions to be true in order for the output to be true. The NOT operator simply takes the opposite Boolean state of an input condition. In other words, an input that is true would evaluate to false and vice versa if using the NOT operator. We'll first look at some examples of evaluating Boolean functions. The following code shows several examples of how compound comparators would be implemented and evaluated. In the first example, the first comparator evaluates to true and the second evaluates to false. So when we take the logical AND of the two, we have true and false, which evaluates to false since both inputs must be true for the output to be true with the AND operation. In the second example, the first term would evaluate to positive 3, working from the innermost parentheses outward, then to true when compared against 3. The second term would evaluate to true since 16 raised to the 0.5 or 1/2 power is the same as the square root of 16 or 4. The resultant AND would evaluate to true since true and true is true. In the third example, the first term evaluates to 3 since 19 mod 4 is 3, then to true when compared to 300 divided by 10, then divided again by 10, which is 3. The second term is true, so when we take true and true, we get true. In the fourth example, we take 1 raised to the power 2, then take the negative of that, which is negative 1, then compare it to 2 raised to the power 0, which is 1, and since negative 1 is less than 1, then this term evaluates to true. The second term checks if 10 mod 10, which is 0, is less than or equal to 20 minus 20, which is 0, so that would also be true. Then when we take true and true, we get true. In the fifth example, we evaluate true and false, which will produce a false since we need all inputs to be true for the AND function to be true. In the sixth example, we illustrate the evaluation with variables, but it works the same. So when we plug in the values for x, y, and z, we see that 5 is not greater than 4 plus 6, so this output would be false. In the seventh example, we check the variable x against the calculation shown. Here, make sure you evaluate with the proper PEMDAS order. So we'd calculate 6 minus 4 equals 2 first, then divide it by 2, which is 1, then multiply by 5, which is 5, and since x is 5, our evaluation is true. Finally, in the eighth example, we check if two strings are equivalent. In this case, all the characters must match exactly, including the case. So here we see a small h in the first term and a capital H in the second, so they do not match and will evaluate to false. Note, if you are familiar with Java, you know that you cannot compare strings using the double equal operator, but in Python we can do it. Now we're going to put the Boolean comparator evaluations together with some conditional statements, but before we do that, we'll discuss the specific Python syntax and scope for these statements. The comparison structures in Python use the words if, elif, and else. The code syntax of the if and elif statements is to surround the evaluated condition with parentheses and end the line with a colon. The code syntax of the if and elif statements is to surround the evaluated condition with parentheses and end the line with a colon. The else statement is just terminated with a colon. No condition is evaluated because this is the catch-all state. In other words, the else is used if all of the other ifs and elifs evaluate to false. Also note the indentation of each of the print statements under each of the if, elif, and else statements. Python defines what's called its scope with indentation. For example, all lines that are indented and under line 4 in the example would be executed if the conditional statement evaluated to true. This is different from other languages such as Java and C, which use brackets to define their scopes. So be careful when writing your Python code to use proper indentation. Now let's check out a few examples to illustrate each of the if, elif, and else statements. In the first example, we evaluate an assigned integer variable x against several values and print out a message based on which comparison is evaluated as true. Since 15 is greater than 10, the first if statement evaluates to false, so we skip the code indented underneath it and proceed to the next conditional. Here, 15 is greater than or equal to 10, so we print out the message and proceed to the next statement. Here, 15 is greater than or equal to 15, it's equal in this case, so we print out the message here as well and proceed to the next statement. Here, 15 is not greater than or equal to 20, so we don't execute its message. In the second example, we evaluate the first conditional statement to true, so we print the message, then terminate the program because the elif and else statements are only executed if the previous statements are false. Since the previous if statement evaluated to true, we do not execute any of the following elif or else statements. In the third example, we evaluate false here, since 28 is greater than 18, and evaluate true here, so we print the message, then terminate the program. Now these are pretty simple comparator operators inside the if statements, but note that we can also use the compound statements as we showed in the previous slides here. Additionally, we can implement multiple if statements by nesting them together in our code. The nesting operation works similar to how a compound statement would work. We'll explain it with a couple examples here. Can you see why the two snips of code here and here produce the same output? If we consider x equals 15 in the example, we would evaluate the conditional here as true since 15 is both greater than 10 and less than 20. Now for x equals 15, we'd evaluate the code here as true, so we'd proceed to the code under it that is indented, and in this case the conditional would also evaluate as true, so we proceed to the code under it and print the message. Python programmers need to be careful with how they pair up their elif and else statements with the corresponding if statements when nesting. For example, what would be printed here if x was equal to 4? Here, we see that this conditional statement would evaluate to false, since 4 is less than 10. But if we look at the elif statement here, we see 4 is greater than 2, so should it print the message at line 41? In this case, the answer is no, since this elif is paired with the if statement here by noting its indentation, and therefore this elif statement is not evaluated since we never got past the first conditional statement here. Now what if x was equal to 14? What would be the output then? In this case, we'd evaluate the first conditional to true, and because of that, we'd proceed to evaluate if x is greater than 20. Since this would evaluate as false, we'd proceed to the elif, and since this would evaluate as true, that is 4 is greater than 2, we'd print out the message here.
Please answer the following question, then hit the submit button. Please answer the following question, then hit the submit button. Please answer the following question, then hit the submit button. Please answer the following question, then hit the submit button.
Okay, so what did we cover in this unit? We discussed Python comparator functions and their operator symbols used when we create conditional statements in our code. Then we looked at the format and syntax of the if, elif, and else statements and walked through several examples of their use. We also pointed out a few potential gotchas that programmers should be aware of, namely with the difference between the assignment and conditional equal operator, indentation scope rules, and pairing elif and else statements with their companion if statements. Next, we will discuss the random number generator function.
Thanks for watching, everyone.